Hello friends, this is Priyanka. Today we are going to solve a problem on hydroelectric power plants. In this video we are going to understand how to draw hydrograph as well as flow duration curve. We are also going to calculate average monthly flow. Let us first understand what is the given data. Now here total period, that is the months, are given. 12 months are given and these months starts from April, that is April, May, June, July and so on. For these months discharge in million meter cube is given. That is for a 1 month, that is we can say for the month of April discharge is 500 million meter cube. For the month of May discharge is 200 million meter cube and so on. Now let us first plot the hydrograph. If we observe this data here, the period of 12 months is given. So whenever we plot the graph, then we have to take the time period on the horizontal line. So on this horizontal line we will plot the period of 12 months. So for one period we will, or we can say for 1 month period, we will take some suitable scale. Suppose we will take here 2 centimeter distance, or we can also take 3 centimeter distance. So from this point, that is starting point up to this point, this whole period is for month of April, then May, June, July, August and so on. Then on vertical line we will plot the discharge. Now if we observe here the discharge, minimum discharge is 200 and maximum discharge is 3000. So whenever we start from 0, suppose we will take here 2 centimeter distance. Then for 2 centimeter distance we will plot here the 200. Then again we will take 2 centimeter distance, then 200 plus 200, that is 400 and so on. So here total distance is 4 centimeters. So we will plot here directly as a 800. Then again we will take 4 centimeter distance and we will plot here 1200, 1600 and so on. So minimum discharge and maximum discharge should be covered. So as per that we have to take some suitable scale. Now we will start to draw the hydrograph. Now if we observe here for the month of April, discharge is 500 million meter cube. So on this vertical line, this is the discharge in million meter cube. So here after 400 we have to take 1 centimeter distance and here the number is 500. So for this 1 centimeter we will plot here as a one horizontal line. Then for the month of May it is 200. So here is 200, that is in between 0 and 400 there is 200. So we will draw here one line. So we will join these two lines. Then next is 1500. So below 1 centimeter of 1600 we will plot here 1500 and we will draw here one line. Then we will join this. Then 2500. So here is 2500. After 1 centimeter of 2400 we will plot here one line and we will join this line. Then 3000. So here for the month of August, here is 3000. So we will draw here one line. Then 2400. So here is 2400. Then 2000. So here is 2000. After that 1500. So 1500 is getting repeated. Then 1500 again. So we will draw here 1500. Then there is 1000. So in between 800 and 1200 there is 1000. So we will draw here one line. Then 800. So 800 is here. Then 600. So last one is 600. That is in between 400 and 800. So this is the last one. Now if we observe, this graph is known as hydrograph. Now we will calculate average monthly flow. So how to calculate average monthly flow? So we have to add all this discharge for 12 months and we have to divide it by the number of period, that is the number of months, that is divided by 12. So we will add all these, that is 500 plus 200 plus 1500 plus we can also take 100 as a common term. So it will be easy for us to take 100 as a common. So I will take here as a 5 plus 2 plus 15 plus 25 plus 30 plus 24 plus 20 plus 15 plus 15 plus 10 plus 8 plus 6. So I will give here bracket multiplied by 100 divided by 12. So whole divided by 12 is there. So if we calculate here, we will get 1460. So what is its a unit? So 1460 million meter cube. Million meter cube. So this is the average monthly flow. Average monthly. So here in this question, the word already included average monthly flow. That is, this is the flow, average flow for a month. Now we will plot here, or we will show here this average monthly flow, that is 1460. So how to show? So here 100 is there and here is 1400. So after 1400 we have to take the value in between 1400 and 1500. So with some suitable scale we will draw here, or I will show here with the help of dash. So this is nothing but the average monthly flow. So we will mention here. Now we will move to draw flow duration curve. For that we will make here one table. So first row we have to select for the discharge in millions of meter cube per month. So the discharge given as in the question, we have to rearrange this discharge in descending order, that is from maximum discharge to the minimum discharge. So we have to take here 3000, then next lower number, that is 2500, 2400 and so on. Then for this discharge we have to write the next row, that is the number of months during which flow is available. Now we have to find out how many number of months are there, that is for this discharge of 3000 millions meter cube per month. Now we have to write this data with reference to of this hydrograph. So for that we will observe this hydrograph and we will write here the number of months. So for this 3000, that is here is the discharge 3000 and the number of months during which this 3000 discharge is available. So if we observe here only one block is getting covered. So one block, that means 1 month. So we will write here as a number of months, that is 1. Next is 2500. So here is 2500. So if we observe here this 2500, this one block, and for the second block also 2500 discharge is available. So total number of months, that is number of month 2. Then 2400. So if we observe here is 2400. So number of blocks are 1, 2, 3. That means 3 months are available. Then 2000. So for this 2000, 1, 2, 3, 4. So here we have to write the number of months 4. Then 1500. So here is the 1500. So here number of blocks are 1, 2, 3, 4, 5, 6, 7. So here number of months 7. Then 1000. So for the 1000, if we observe here, here is the, in between this 800 and 1200, here is 1000. So number of blocks available, that is, we can say that here this is the first block, second, third, fourth, fifth, sixth, seventh and 8th. So here 8. Then for 800, so for 800, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then for 600, so in between this 400 and this 800 there is 600. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then for 500, so for this 500, if we observe, this first block is also having discharge 500. That means we can say that in the month of April there is the discharge of 500. So we will select this one block. So here is 1, then there is the gap. So this is the first, then here is second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11. So here is 11. And then we will move for 200. So if we observe 200, so here is the block for the month of May, that is having discharge 200. So if we observe, all the months are getting covered for the discharge of 200, so we will say 12. So we have to complete this second row with the help of the hydrograph. So this is the hydrograph. Now we will move for the third column. So what is this third row? That is percentage time during which flow is available. So this is the calculation part. So percentage time we have to calculate. Now if we observe, this discharge 3000 is available for 1 month. So number of months are 12. So out of 12 months, only 1 month is available. So out of 100, how many percentage that we have to calculate? That means if we cross multiply, then 100 divided by 12. That is 8.33. So here 8.33 is the percentage time. Then in the same way, we have to take out of 12 months, 2 months are available. Then what is the percentage of time? So 200 divided by 12. So it is 16.66. So I will write 16.6. Then for 3 months, again we have to take 300 divided by 12. That is 25. Then for 4 months, that is 400 divided by 12. That is 33.33. Then 7 months, that is 700 divided by 12. That is 58.3. Then 800 divided by 12. That is 66.6. Then 900 divided by 12. That is 75. Then 1000 divided by 12. That is 83.3. Then 1100 divided by 12. That is 91.6. And then all the 12 months are available. That means 1200 divided by 12. That is 100%. So in this way, percentage time during which flow is available. So these months out of 12 are getting converted into percentage time. Now in flow duration curve, we have to plot this percentage of time on the horizontal line, and on this vertical line we have to plot the discharge. So discharge in millions of meter cube per month, that we have to plot. So we have to start from 0. So here is 200, 400, 800, 1200 and so on. So in the same way as earlier in the hydrograph, we have to plot these numbers. Now for the percentage time, total percentage is 100. So we will divide it into 10 parts. That is, we will start this from 0. Then here is 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Now how to plot this flow duration curve? Now we have to refer this discharge and against this percentage of time. Here is also discharge against percentage of time. So for this 3000, discharge percentage is 8.33. So we will select here the points. So 8 means 8%, that means it is before 10. So we will select here one point, that is approximately this is 8%. Then for next 2500. So here after this 2400, this middle point here is 2500 and percentage is 16.6. So 16.6, that means in between this 10 and 20 there is 15. So after that it is 16. So we will plot here approximately this point. Then for 2400 it is 25%. So this is the line for 2400 and 25, that means in between 20 and 30. Then for 2000 discharge it is 33.3. So for 2000 discharge it is 33.3. Then for 1500, so 1500, that means here below this 1600, for 1500 it is 58.3. So 58, that means before this 60. So we will plot here this point. Then 1066.6. So here is the 1000 and we have to take percentage, that is 66.6. That means here. Then 800 it is 75. So for 800, in between 70 and 80 we have to plot 75. Then for 600 it is 83. So for 600 we have to plot here 83. Then 500. So here 500 it is 91. And then for 200 it is 12, that is 100%. So these are the points that are getting selected. So now we will join all these points. So this is known as flow duration curve.